Welcome. Thanks for coming today. To help me get a quick sense of the audience, how many people have already attended live services talks? Great, fantastic. How many people are using the Live Mesh product? Great, fantastic. Today we're going to talk about a couple things. We're going to talk about communication, and we're going to talk about being connected. Now, before you head for the door, this is not a self-help talk. This is the PDC. We're talking about technology. We're talking about communication services and how they enable connected experiences. My name is John McIntyre. I'm a group program manager with the Live Mesh and Live Services team. For the last couple of years, I've been working on the Mesh project and the underlying services that power Mesh, those services that are now available to you as developers through the CTP. Prior to that, I was in the Windows Core Operating System division. So you could say that I'm a runtime and systems guy. That is my background. I'm responsible for the live operating environments. These are the operating environments that do service composition and synchronization of data. So if you've been to Live Services Talk, you've probably seen this slide or some variation of this slide. This is the live framework blown out. And as we think about the live framework, we think about the libraries, the SDKs, the developer-facing features, and then the resources that power those SDKs and libraries and the services that power excuse me, those SDKs as well. And then at the bottom, we think about the live operating environment. Again, this is the service composition runtime. It also performs things like data synchronization and connectivity. So the you are here for today is this box. We're going to talk about communication services and specifically the communication stack. This is the same communication stack that powers the Live Mesh product and the same communication stack that's available to you now through the Live framework. Specifically, what I want to cover today are a couple things. I want to talk about connected experiences. And I want to talk about how users' expectations around connected experiences are evolving. Then we'll talk about the communication services. What services are available for the Live framework that help you deliver connected experiences? Specifically, we'll talk about three components. We'll talk about connected data. And this is the change notification and subscription system. We'll talk about connected devices, the overlay network that exists in the peer-to-peer channels that help you connect from device to device and communicate across devices. And then third, we'll talk about connected users. So activities, news, and awareness services that help you create experiences where users can start to engage. So let's spend some time on connected experiences. I think for the last 10 to 15 years, when people have talked about connected experiences, largely they've talked about connected to the web, connected through the browser, and through the internet evolution, people have been accustomed to having their connected experience through a browser. However, recently, as people have more devices and these devices are connected at birth, users' expectations are changing. Users want experiences that are connected across devices, connected to the web, connected to rich clients. And so it's no longer sufficient to say, I'm going to deliver a browser experience, and I'm going to deliver that on every device. In fact, we see that device-optimized experiences are important. I want experiences on devices that feel natural to that device. If you recall from Ray's keynote, he talked about the PC, the web, and mobile, and the experiences on those devices and tying them together. As a user, I want those experiences to feel natural. I want them to feel natural on the device, and I want them to feel seamless as I go across different devices. The engineering reality, or the reality of this, is that it's extremely difficult to build these sets of experiences. There's a lot of heavy lifting that we as developers have to do to even stand up basic scenarios. Ultimately, you end up building things like storage services, relay services, authentication services, device connectivity services, and you may not build these entirely up to their full capabilities, but you likely build enough to get your scenario off the ground. And inevitably, as you build those services, it's highly unlikely that they interop well with other devices or other services. So you do all this heavy lifting, and then at that point, you can start thinking about what is the experience that the user is going to get? What connected experience do I want to deliver? So the end result for users as we build these systems is that we create these islands. So today we have a lot of islands. Devices create islands into themselves where they capture data or they hold data on that island. They have experience islands where I'm used to a specific experience in the web and I may get a completely different experience on the rich client. So as we start evolving live services in the live framework, one of the things that we think about is how do we get off that island? So how do we build a set of frameworks and services that allow users to get off those islands, get off those device islands, get off isolated data islands, get off web experience islands? And so we fundamentally feel that services and devices working together can enable those scenarios and enable those connected experiences. So as we were developing the live framework and a lot of the services that power mesh, we thought about 3 steps to getting off the island. So the first is we think about unlocking the data. So how do I really start to deliver on the promise of anywhere access to data? Stephen Lees did a talk earlier this morning on data synchronization, feed sync, and how it interacts with the platform. If you didn't get a chance to catch that talk, I highly encourage you to go check it out online. It'll be there within 24 hours. But it really starts to describe how we think about data, how we think about data in the mesh, and how we think about data being available, delivering on the promise of anywhere access to data for both users and developers. And then the second step, so we talk about unlocking the data. The second step is lighting up devices. So how do we build runtimes and operating environments where you as developers, as you operate on one device or another device, can ensure that you have consistent capabilities and you interact with the platform in a very seamless way? Jeremy Masner, I think, just finished a talk on the world of devices. And this will give you a sense, if you got a chance to see that, how we think about devices and devices interacting in a mesh, or a mesh of services where users get those connected and seamless experiences. So 1, we talk about unlocking the data. 2, we talk about lighting up the devices. And then 3rd, what we're going to spend the bulk of today's talk on is connecting those things, connecting the data, connecting the devices, and being able to deliver these connected experiences. So these are the communication services that really start to connect the data in the devices. And the things that you get through those communication services are proximity. Proximity to the data that I care about, independent of that locality of where that data actually is. I get proximity to the devices. I can address devices in a consistent and uniform way. And then once I start to connect the data in the devices, I can start to build experiences for users where they engage. And so communication services also delivering some of the services where you can connect users. So we think the communication services are key to getting off the island. And this is through this consistent, approachable framework that brings together devices, data, and users. So before we get too far, you're probably saying, well, that's fine, all theoretical, but what does a connected experience look like, Microsoft? You guys are talking about these connected experiences, and certainly Live Mesh is a great example of what we think a connected experience is. But it's not just about data sync or file synchronization or remoting from one desktop to another desktop. So we've worked with some teams at Microsoft and started really thinking about what are the connected experiences they can start to deliver. So one example here I'm going to show you is Media Center. For those of you that know, use, and love Media Center, you're probably familiar with this. This is the programming guide. It's available on my Media Center. So I'm on my Media Center. The scenario here is I'm on my Media Center at home, and I can access that programming guide, and I can record things and make choices on what I want to watch. So we started thinking, well, this is interesting data, and it's not just interesting data in the context of Media Center or me being in front of my Media Center, but what if we were to start to unlock that data, make it available on other endpoints, on other devices? What types of experiences could we enable? So there's a piece of code running on the Media Center that does a very simple pull of the Media Center guide, and it pushes it into the mesh and replicates that around to other endpoints. I'm now going to switch over to my other device. This is my work laptop. I'm at work, the scenario here, and I said, hey, I'm not going to make it home, or I'm doing this talk at the PDC. I have my laptop with me. I'm not going to make it back to record what I want to record. So how can I get to that data, and how can I make changes to that data that will seamlessly flow back to my media center? So I'm going to fire up a mesh application. This is on the client. If you went to the mesh application talk yesterday, you probably learned a little about mesh application. This is a Silverlight application running out of the browser. And because this device is part of my mesh, that application is available to me. It's available to me offline and online. So what that application is doing is it's actually loading that programming guide now. So you can see there's my experience. I can see the programming guide. I can access it. So let's go ahead. Probably going to be in this talk past 1, and I really like my soaps. So let's do One Life to Live. One Life to Live fan in the back. This is for you. All right. So what I've done there is I've set the recording option on this mesh application that is on my laptop here at the PDC. And we'll go back to the media center view. Oops. Oh, wow, that was too fast. So we can see that One Life to Live is already set there to record. That data is synchronized back to the media center. The media centers pick that up. And you can see a very simple scenario around connected devices. But I think we talked about PC, web, and mobile. So I'm going to show you another scenario here. Let's go back to this laptop. I'm going to quickly show you that. Let's see. This application is also available in my web desktop, so I could run it there. It'll look exactly the same as it does on my desktop. Let's see if we can refresh it. Oh, there we go. Same application there running in my web desktop. Now let's say I go to my mobile device, and my mobile device is part of my mesh. It's synchronized with all the data, and everything's also available on that. So I want an experience on my mobile device that feels natural to that device. So here you can see we have this mobile device tethered to this laptop so that we can see it on the projector there. But this mobile device is running a very simple application that renders the programming guide and allows you to do some of the basic interaction with that programming guide. So let's go and take a look. I'm going to be on a flight later. So let's scroll down. Big Seinfeld fan. Yeah, so let's go and record that. So we'll set that to record. So what this device now is doing is it's actually through the operating environment. It's actually running a very early version of the Windows Mobile 6 live operating environment and synchronizing that data back to this media center. So through the magic of software, you'll get to see it show up this time, hopefully. We'll see how well our demos are behaving today. This is actually running against the developer platform production cloud. So a lot of the bits that you're going to see today, both on the client side and the cloud side, are available to you. The mobile client will be releasing that over the next coming months and so. You'll see a live mesh client available for Windows Mobile 6. Oh, was it 7:30? Oh. Ah. Thank you. And now you probably don't believe me that it's synced, but that's okay. All right, so really simple scenario around connected experiences, taking an experience that today is very device-centric and very data-centric, starting to expand it to other devices. And then once we do that, we can also start to think about how would I expand that to other users? What if I'm sharing my media center within a family and I want to collaborate on the media center guide? I want to see why my wife canceled my 8 hours of football that I want to record on Sunday. And so enabling a social aspect of that as well is how we think about these connected experiences. So let's start to drill down on some of the communication services. These are the communication services that power these connected experiences. And again, these are all about connecting data, connecting devices, and connecting users. I'll keep pounding on that throughout the presentation. If you haven't guessed, that's the thing you should take away. So as we think about connected data, this is the subscription and notification system. I'm going to spend some time talking about the services and how they run, how they're architected, and then pop up to the top and say, what does this look like to you as a developer? How do you register for change notification? How do you tune into the data that matters to you? As you think about the live framework as a very broad, deep directory of objects that are synchronizing across multiple devices, objects that can be online, offline, allow for concurrency, sharing, it's a little overwhelming. So quickly you want to tune into the data that matters to you. And that's really the subscription and change notification system that allows you to do that. Then we talk about connected devices and providing a peer-to-peer network and overlay network so that you can communicate across devices. You can move messages and data from one device to another. And then finally, connected users. We'll talk about the news and awareness services that you can plug into today and start to create engaging experiences for your users. So first, let's talk about subscriptions and notifications. And this is the connected data piece. As we were designing the change notification system, there are a few themes that prevailed. So certainly simplicity. It was really important that as we think of the live framework as a very resource-oriented directory that you interact with that's powered by services and enabled through operating environments, it's got to be a very simple extension or something that feels very natural to that resource model. So if you're used to using REST and interacting with resources, notifications and subscriptions should fit nicely into that model as well. Then we think about scalability. How do we scale out to service hundreds of millions of subscriptions? How do the services then behave when there are faults, and when failures happen, what kind of resiliency do we build into these services? So I want to start to dissect a little bit the subscription and notification system. Subscriptions and notifications are powered by two key services. One is a queue service, the other is a subscription service. Both these services run in the cloud and run in the Microsoft data centers. This is the same service, change notification service, that powers the Live Mesh product, if you've used the Live Mesh product. These two pieces interact quite closely. So the queue service is effectively a service that manages queues for a given user in a given application. So think of it as you as an application say, hey, I'd like to create a queue, and then I'm going to use that queue to subscribe to change events on other resources. It's effectively like going to the post office and saying, hey, post office, I'd like to open a mailbox. Please give me an address. I'm going to use this address to subscribe to things, and people are going to send me information. So you actually get a URI back from the queue service. This is a URI that you can use and then start to attach to different resources. The subscription service is responsible for managing subscriptions to a particular resource. So you have a resource element and then subscriptions hanging off of that resource. Both of these services run as multi-instances, and we'll talk about how that allows us to scale out. So how do you interact with this as an application developer through the Live framework? Both as a web application or a client application, there's symmetry in how you would interact with this service, and both of which you would interact through the Live framework. Through the Live framework, you could subscribe to a change event. That subscription is then forwarded to a resource manager. There are a number of resource managers in the system. There's a storage resource manager, and there's a device connectivity resource manager. Resource managers effectively are somewhat self-explanatory. They manage specific resources. That subscription is then forwarded to the subscription service, and the subscription service hangs on to a particular resource and what notification queues need to be notified if a change occurs. A change then occurs in the system, either through your application or another application. I'll show in another demo where we actually register for change events on shared objects so that I can integrate across experiences and across applications. But once that change propagates to the subscription service, the fan out happens to the queue service, and effectively we drop information in each queue that's subscribed. That notification is then propagated over a transport. Today in the Live framework, we support HTTP as a transport. We're actively developing a TCP transport that Live Mesh is actually starting to use for its devices and device connectivity. That notification then comes down to a client, either a device or a cloud experience can also get that change notification. And then the application can then decide what it wants to do with that change notification. So this is effectively how the subscription and notification services work. And by now you may be saying, wow, that's a lot. As a developer, are you really going to expose all of that to me? Do I have to do all of that? The short answer is no. So I'm going to show you some examples in code where you interact with the subscriptions and change notification service and how this is really distilled down to something very simple for you. However, if you're a developer that likes to use REST and likes to interact with services via protocol, you can do that, and you can interact through the subscription and notification services through these protocol interfaces. So the couple obvious questions come up when we talk about subscriptions and notifications. The first is scale, the second is recovery. How do we think about scaling this service to hundreds of millions of subscriptions? So we refer to this as horizontal scale. So how do we scale out the service horizontally? How do we bring up multiple instances? How do we ensure that each of those instances is consistent about the resources that it manages? So there's actually a system behind the subscription and notification service called the partition manager. And the partition manager is responsible for scaling out those instances and ensuring that they're addressed uniformly and that resource managers know where to send their requests. So depending on the load of the system, we can turn the dial on how many instances of the subscription services are running and start supporting more resources. And that's how we get some of that horizontal scale. The other thing to note is both the subscription service and the notification service or notification queue service are in-memory tables, so we never hit the disk. And we also enforce time to live. So there's a time to live to apply to a subscription, and when the time to live expires, it may be up to the application to go renew that. However, if you're interacting through some of the SDKs, a lot of that is handled for you, and I'll talk about that when I show you some sample code. So what about failure modes and recoveries? There are two failure modes that we think about. One is if a subscription service instance goes down, then the other is if a notification queue instance goes down. In the former case, this is effectively like the post office saying to you, one of our trucks got lost on the way to the post office. We lost a bunch of your mail. And so what the system will do is it will notify you. It will say, resources from these addresses have lost subscription, so you should think about going back to these resources and checking to see if there are any changes. A notification queue loss can be a little more involved. Effectively, what this means is, you've gone to the post office or you go to get your queue and it's gone. They say they lost it or caught on fire or whatever. And they say, sorry about that, we'll give you back a new address, and then you can use that address to resubscribe. Again, if you're interacting at the protocol and service level, a lot of these things you'll have to do and respond to state loss notifications, respond to queue loss notifications. If you're interacting at the OM or through the client libraries, a lot of this is managed for you. And in fact, this is seamless to your application. But the important point to note is that the service will recover, it will alert you, and you can respond appropriately. So I want to take a brief sidetrack and talk about some of the lessons that we learned running some of these services. I think it's interesting. PDC is an interesting forum where we can start to share some of these stories with you, enforce that we are human, yet we are constantly improving these services. I talked about TTLs applied to subscription objects. So when we launched the mesh product back in April, one of the design points we had was that we would enforce TTLs, and at the time we really wanted to put variability into the TTLs, but we didn't have time to get that in and get it into production, so we said, we'll set the TTLs at 2 hours. We should get enough variability of devices coming online, offline, different variable patterns in application usage. And so for the most part, we felt pretty comfortable making that decision, knowing that in the future we wanted to add variability to the TTLs. So we launched in April. Subsequently, Patch Tuesday came around. If you're not familiar with Patch Tuesday is the Tuesday of a month where Microsoft releases security patches. Inevitably, what this means is a lot of Windows machines reboot. So we saw some interesting patterns in the system. Specifically, when we looked at load on the system, you see two distinct dips here. One is a dip on the East Coast when all these systems went offline. Then the next one is on the West Coast when all these systems went offline and then came back online, and you see the load on the service starting to ramp up. The system is designed to account for these things, and we build out scale to account for these types of spikes in the system. That said, what we didn't anticipate was the repeating pattern that it introduced. So as we saw this happen and we saw machines come back online, we noticed that the subscription service was periodically pegging on CPU. So we have a lot of instrumentation and monitoring in these data centers. Alarm bells were going off. Every 2 hours, alarm bells were going off. And so what was happening is all of these devices were coming back and resubscribing at the same time. So subsequently, this caused us to speed up our implementation of variable TTLs, but certainly a lesson learned. And over the course of the next few days, that repeating pattern started to go away as the load started to distribute and people started to get back into their regular practice of logging on and off different machines. And so you saw that go away after a few days, but certainly a lesson learned as we think about running some of these high-scale services. So let me get back to notifications, subscriptions, and what they look like in the resource model. If you've been to a number of the live services talks, you may be familiar with the resource model. The resource model basically represents different objects in the live services directory. So as we think about subscriptions and notifications, the goal is for it to just be a natural extension of the resource model. So if you're talking Atom Pub to us, then it should just look the same. So hanging off of a mesh namespace is a notification queue. You can just post to that notification queue, and we'll hand you back a notification queue instance, and you can use that URI to then subscribe to objects in the directory or among the live services. So today, all of the mesh services are subscribable. Over time, we'll be adding that capability to other resources at the higher level, specifically profiles and contacts. Okay, so we went fairly deep into how does the subscription and notification service work? What are the expectations around an application if it were talking protocol directly to the services? But I promised you that it wouldn't be that complicated for you as developers. So let's go look at a very simple WPF application. So what I have here is a very simple rich client application that interacts with the mesh through the cloud-based live operating environment. So let me just hit F5 here. And we'll run it. I'll log in. You can see I'm hitting the production cloud. I don't know if we still have Andy in the data center, but we'll see how we're doing today. So if you go back, connecting, and look at this application and what it's doing, I'm just doing there's some simple code here that basically populates a view of mesh objects. It loads up, it talks to the service, and it populates that view. So here's that very simple WPF application. You may ask why it's got a notepad or why it looks the way it does. It used to look a lot worse. I'm not a UI guy, but I gave it to our designers, and this is what came back. So the intent is you can build a really simple client-side application that interacts with the mesh and interacts with the live operating environment. So I'm going to show you a couple functions in this particular project. So we have some breakpoints on the subscribe method. So we talked a lot about how do I interact with the notification queue service, how do I interact with subscriptions, how do I interact with resource managers. Effectively, what this boils down to is registering event handlers. Plus equals, I register the event handler, and I can register the event handler at the level of mesh object that I want to. So let's see if we're back. We're back. Okay. So we've loaded all the mesh objects. And on the left there, you can see the view of all my mesh objects. And there's a button at the bottom. You saw the breakpoint probably. So let's go and subscribe for a change notification on one of these objects. And the other thing I want to note is these aren't just live folder mesh objects. These are, in fact, all the mesh objects that are in my mesh. So you'll see a number of other mesh objects, like the web guide mesh object. This is the mesh object that the Media Center application was using. It has a programming guide mesh object. But I'm going to go ahead and subscribe to the documents mesh object. So effectively, the only thing I'm doing here is I'm registering event handlers for change notifications at the mesh object level, at the news level of a mesh object, and then at a data feed and data entry level. So let's go ahead and run this. I'm going to switch over to the live desktop. So I believe it was documents that we registered for a change notification. So this is running in the cloud. This is the live desktop. It's running in the cloud. I'm also running this WPF application that's running on the client. So let's go ahead and let's actually change that mesh object and see what that looks like on the client. So I'm going to go ahead and upload a file. Let's see here. I love the Vista pictures. Big fan of the sea turtle. So let's upload that. Oops. Oh, we got a couple up there. I wonder how we're going to handle that. We'll find out. OK. So let's switch back to this client-side application. So you see there that data entry, if you look on the top right there, before we switched over to the breakpoint, that I was starting to get change notifications. I have a breakpoint on news change notifications. So I'm actually getting that notification on the client runtime, or sorry, through the cloud runtime down to a client application. So you can see here how it's really simple for me to get those change notifications and then do something interesting with that change notification. We have another here for data feeds. The only thing interesting I'm doing is I'm actually just updating some status text. There's my other file. Nope. May get another. So the point here is that there's a large service running in the cloud that is highly scalable and reliable. And we talked about how that service runs and how that service is interacted with. But through the client-side libraries, a lot of that is simplified for you. So the client libraries are actually doing the subscription for you. They're doing polling for you. They're actually looking at the notification queue periodically, checking to see if there's anything in that notification queue. If you get a queue loss, the OM will handle that for you. If you get a subscription loss, the OM will also handle that for you, and then it'll go and take care of a lot of that lifting for you. So I'm going to go and close this. I think we're doing OK for time. So I'm going to show you something slightly off script. You saw in the application when I fired it up, I was connecting to the cloud live operating environment. What I'm going to do now is I'm actually going to retarget this application to talk to the client, and then show you how, the same things, the same code that's effectively running against that cloud live operating environment can run against the client live operating environment. So let's go ahead, change this, comment out this section. So now I'm doing a connect local. So we'll hit F5. So at this point, I actually don't need to provide credentials. I'm not going to pass a password in. The cloud URL isn't even used in this particular case. It's actually going to hit the local runtime, which is exposed over localhost. And I've already logged in to that local runtime, so this should just connect. There we go. And you'll notice because I'm hitting that client-side runtime, it's a lot faster. You saw some of the latency when I was hitting the cloud, but really getting the benefits of client-side runtime, client-side software. So let's go do the same thing. We'll subscribe to this documents mesh object. I'm going to hit F5, let that run. We've registered for change notifications and documents. Let's upload another file. Let's go with winter leaves. Winter's on its way. Seems appropriate. So what the client runtime is doing is periodically syncing with the cloud. And so all of those notifications, the same notifications that were happening through the cloud runtime are also exposed through the client runtime. Now, the thing that you'll see with the client runtime versus the cloud runtime is a little bit different latency in different places. So change notifications, because it's asynchronous, may take a little longer on the client for that data. Effectively, we're waiting for the data to synchronize down for the client to get the change notification. Let's see if we're registered for that. Let's try a post. So hopefully our client is up and running and synchronizing. It may be a little slower today. We're waiting for that notification to come down. Okay, so I think I'll probably move past this. We may actually, there may be a service issue, or there may be an issue with the client software. Again, this is all CTP stuff. I guess the risks of running live code that's been released for one day. But maybe we'll come back to that and we'll see if we get that change notification at some point. Okay. So that was a quick demo about how you could use change notification in the system. And really, as we think about connected data and getting awareness around the data that you care about and getting proximity to the data that you're interested in, how you use change notifications to enable that through your experiences. Let's talk now about connected devices. Specifically, I want to talk about peer-to-peer communication and the overlay network that's provided through the Live framework. There are a few guiding principles as we think about the peer-to-peer network and device-to-device communication. Specifically, we think about seamless communication. So independent of network topology, whether they're firewalls, routers, or whatever's in the way of your devices and how they may want to communicate, this needs to be seamless. And we can't expose this to you as developers, and the desire is not to expose this to you as developers. The next principle is secure. So how do we ensure that devices are trusted devices, they are who they say they are, and that they have a relationship such that they can connect to another device? And then finally, we think about reliability. How do we use some of the services that have been true and tested through Microsoft? We'll talk about some of the services, reliable services that we use to deliver the peer-to-peer and overlay network for communication. So here's a quick overview of the peer-to-peer connectivity. Here you have two devices, Bob's work device and Doug's work device on a LAN, and then you have Bob's home device, which are off on this home network. There are three components that make up the peer-to-peer connectivity system. The first is the identity authority. And this is really the system and service that assures the device is who it says it is. So similarly to how users authenticate, devices also authenticate. And they authenticate through this account service. The account service is responsible for the relationship between users and devices. And then as a backing identity provider, we use Live ID. The second component is the signal channel. So this is the channel, how do I get a message from one device to another device? If I want to establish a connection from Bob's work device, how does that happen, and how does Bob's home device get notified? You'll notice here that this actually just uses the same subscription and notification system that we talked about in the previous section to power device connectivity notifications. There's a resource manager called Device Connectivity Resource Manager, and that fires notifications through the notification service. Interesting parties, specifically devices, listen for those notifications and then act on those notifications. The final piece is the data channel. How do we get data from one endpoint to another endpoint? There are two components of this. One is a direct TCP or true peer-to-peer connection, and then the other is a relay connection. So in cases where we can't establish a peer-to-peer connection reliably, then how do we use a relay in the cloud to get that data from one endpoint to another endpoint? You'll notice here that we're actually using the Messenger relay service. This is the same relay service that powers Messenger that allows for voice chat and file transfer within Windows Live Messenger. And this is the service that's also now available to you through the Live framework to do device-to-device data transfer. So let's show an example of what this looks like and how this interaction looks like. Specifically, I'm going to talk about live mesh folders. I'm going to talk about how that peer-to-peer data transfer works for live mesh folders and the interaction from one device to another device. So let's start with, on Bob's home machine, we'll create a live folder. That's our famous blue folder that gets created on his home machine. Once that's created, the device will actually send metadata surrounding that folder to the storage service. This is one of the resource managers that we talked about in the cloud. The storage service will then fire a notification that this particular object changed. That notification will then land on Bob's work machine. So Bob's work machine is now aware that that live folder exists on his home machine. Bob's work machine can now decide how it wants to handle that particular notification. In this case, and in the live mesh and live folders case, we actually go and we get the metadata. I said, that sounds interesting, let's go get it. Let's see what it contains. So Bob's work machine pulls down that metadata and then looks at the metadata. Within the metadata, Bob's work machine can see where does this data actually reside, or what are the addresses or endpoints that actually have this data. Now, as an application, this isn't really exposed to you or even that interesting to you in terms of establishing a peer-to-peer connection. All of this happens within the live operating environment. So the live operating environment will then post to the device connectivity entry, to the device connectivity service. Bob's home machine will get a notification from device connectivity that effectively says, hey, there's a machine that would like to connect to you and that would like to get some data from you. So these two devices try to communicate. There are a number of ways they try to communicate. They try to establish a connection. First, we'll try to do a TCP connection. We'll try to establish a direct connection to that device. That will then fall back. So in this case, we're not on the same network. In the future, we're actually adding NAT traversal and some additional features around the P2P infrastructure. So there'll be more cases where we're going to be able to hop networks and do a true peer-to-peer connection. So in this case, we'll fall back to the messenger relay. Bob's work machine and Bob's home machine will rendezvous in the cloud over that relay. And then data will start to transfer over that relay over to Bob's work machine. So we see data flowing there as red dots. And it lands on Bob's work machine, and there's my live folder. So if you've wondered, how does this live folder thing work? How does it know when I'm off my corporate network and when I'm on my corporate network? How does that data actually get from one place to another? This is an example of how we use the P2P infrastructure to enable that scenario. So I don't expect you to read this. I want to talk about a couple concepts. So one is devices in the mesh. So the key thing to think about when we talk about peer-to-peer and device connectivity, today, device connectivity or peer-to-peer communication is implicit through the platform. What do I mean by that? Well, what I mean by that is you can say there's data that exists here, and then you can say, I know of all these devices. Please make sure the data is here, here, and here. And then the platform and the runtimes will take care of finding the most efficient way of getting that data realized to particular devices. So what does this look like in the resource model? So under the live mesh namespace, there are a number of devices. Specifically, this is my mesh devices. I have 3 devices. One is my laptop that I use at home. One is my ThinkPad for work. And the other is my desktop back in Redmond. All of these devices have addresses. They have URIs so that I can reference them and address them in the system. So the key point here is devices are addressable, and then I can use that information against resources. So now let's go look at mesh objects and talk about what happened in the live folder scenario. Mesh objects have an ID. I didn't expand the ID there. You'll see at the top, ID is a placeholder. And for each mesh object, there's a mappings feed. The mappings feed defines what device that the data is actually realized to. So what I can then do programmatically is I can actually post a device to the mappings feed. And then the operating environment and the live runtimes will then make sure that that data is realized to that device. They may use direct peer-to-peer communication. They may use the relay. So this is what I mean when I talk about implicit support in the platform for P2P and device communication. Now, in the future-looking things, as we think about evolving the platform, we're absolutely investing in how do you as developers exposing a peer-to-peer channel. So saying, hey, I can address this device. Now I want to establish a connection to this device and stream data across to that device. So these are things that we're investing in and we're looking at and we're actively doing development around. So those are things that you can expect in future versions of the platform to be supported. So that's connecting devices. That's what we think about. We've talked about connected data through subscriptions and notifications. We've talked about connected devices through the overlay network and peer-to-peer. Now let's talk about connected users. There are two key services that enable connected user scenarios. The first is the activity service. Think of the activity service as a great service for moving state around, specifically transient state. So things like, hey, someone's online. Hey, someone's in a folder. Hey, someone's watching Media Center right now. And so you can create engaging experiences and move that state around in a reliable way. The activity service is actually architected in a very similar way to the subscription service and the notification service. So it's all in-memory tables intended to be highly performant. Today, the activity service is only exposed through the resource model. We actually don't have SDKs and client-side libraries that expose the activity service. So today, you actually have to use through Atom Pub interact with that activity service. However, we will be incorporating that into the OM and client-side libraries so that you can do really cool scenarios around, presence, activities, and transient information. The other service is the news service. So if you've used Live Mesh, you've probably seen the news pane. There's a news pane on core objects or mesh objects, excuse me. And then there's a user-scoped news feed. So the news service is responsible for populating and aggregating those feeds, either on a mesh object level or a user level. And when we think about news events, these are really durable events. So if you wanted to do something, if we go back to that media center and add a news event that said, John scheduled One Life to Live to record, so that my family now knows that I'm a One Life to Live fan and I want to watch that. And so I can do things like represent state changes and who initiated that state change, and then start to persist durable state information through news, and then start to connect users and build experiences that connect users. So let me show you a really quick sample of how we use news and awareness in the system. So I'm going to go back to my very simple WPF application. Looks like I did not get those change notifications. Lucky I am responsible for the client-side runtime, so I can go get that bug fixed. All right. So I'm going to go and switch back to the cloud really quickly. Okay. So let's run that again. Switch over to this. So what I want to show is, through your application, how you can start to expose social elements through news. So really simple, a few simple lines of code, you can add things like news events to mesh objects, and you can start to create awareness and user engaging experiences so that if I have shared objects, then people can see what's going on in that object. And I'll show you how that gets exposed through some of the common UI elements in Live Mesh. But certainly when you think about cross-device or cross-application experiences, if you want to create news and awareness events, you can simply just add to that news feed for that mesh object, and that'll start to appear in the Live Mesh application, but also other applications that may be consuming the news feed. So let's switch over here. So what I'm going to do is I'm actually going to post to this mesh web guide mesh object. This is actually the mesh application that's running on both the client and the cloud. And so I have a breakpoint on this post when I actually hit post, and you'll see the code behind that. So I'm gonna post to the, you'll see this post item appear in both the client side and the cloud side web guide application. So we'll say, hey, we should watch, what do we want to watch? Let's watch Matlock tonight. All right. So very simple code here that just says my mesh object, news, add user post. So this is actually, these are some extensions that we've built on top of the OM. We're going to release these online. So if you go and you start playing with the OM today, you'll see, hey, news doesn't have user post, but we're actively incorporating that into the OM. And so there are some extension operations here. But basically, I'm just passing that text, and that'll show up as a user post event. So let's run that. And we'll go back to our web guide. Whoops. I think we had one up already. That was an old, hey, we should watch Matlock. So we'll see that appear in the news pane. So the intent here is to show that even across applications, I can have news events propagate and awareness and create engaging experiences from one application to another application. Let's see if we got it over here. Ah, there it is. Great. So really simple, extending your application and creating some engaging experiences across users. So the scenario here would be if I have multiple users actually accessing this guide, that I can add news and awareness and presence events to that application. So the key takeaways from today are, we talked about three things. We talked about connecting data. We talked about the notification subscription services that power connected data, how some of these services work, and then how you as developers get access to these services through some of the client-side OMs, and how this functionality is exposed to you. We talked about connected devices and the rich communication fabric that connects these devices. And then finally, we talked about connected users, activities, news, and awareness, and creating engaging experiences through mesh object news feeds and the activity service. So with these three things, we really think that you can start to create connected experiences, and experiences that span devices, span the client and the cloud, and really start to engage users. So the call to action, or what you should do walking out of this room, get on the LiveFX Tech Preview. There's still availability back in the pavilion. Go talk to the people at the pavilion. They can get you a code, get you access to the cloud, get you access to the runtimes and the client-side OMs. Start building new experiences. Start extending your existing experiences. Please, please, please give us feedback. We'd love to hear your feedback. This is a technology preview, so we're still iterating and iterating and iterating. but we really want to get your feedback and understand what you want to build on this framework and with these services. And then finally, I'll say, sign up for the Live Mesh beta. I know a number of you said that you were using Live Mesh. This morning, we actually propped a new build. We made available the Mac client. We made in limited availability, we're beginning to make available a Windows Mobile 6 client. So that's available today. That will become available today. And you'll get a new client today. So those happy about the Mac client and the Windows Mobile client. And there's a lot of new functionality in the beta build. We're taking Windows, the Windows client, and the cloud offering to a beta level. So we've added some great features. We've added role support. Go check out our blog. You'll see everything that's added in this release of Live Mesh. So we're really excited to get feedback on that as well. So give us feedback on LiveFX, Live Mesh, and enjoy yourself. Don't forget evals. So it's important for us as doing this PDC that we get your feedback. Keep in mind, I have no control over the room temperature. So I've seen a number of pieces of feedback where temperature is the key issue. OK, so I'm going to open up the Q&A. I am going to ask people to use the mics because we are recording. So if you have any questions, now's the time. OK, thank you. I'll stick around.
Can I ask a question?
Sure. Sorry, I did.
How about devices to servers where you want to collect data in the field on your various devices, then push that up to the mesh and bring it back to your end servers, where
right.
The end server might not know the user's ID?
So the question was around, how about, let me try to play this back and you can tell me if I'm interpreting the question correctly. So how do we think about pulling data from devices and then extracting it at the cloud level through a third-party service? Is that inaccurate?
Yeah, right, where the users subscribe to allow the information they're pushing, or
right.
The client app that subscribes to the information pushing is available. So like firefighters collecting data in the field, and it goes to a centralized database for reporting for their department.
Yep. So a couple of pieces there. So one is how we interact with other data sources. Stephen Lees did the talk on FeedSync. I don't know if you had a chance to hear that talk, but that's a great way to interact with the Mesh cloud or the LiveFX cloud and to basically synchronize data from that cloud. And then the other element is we think about delegated authorization. So the service has to have permission to pull that data, the user's permission to pull that data from the cloud. And assuming it has delegated authority and you're implementing and interacting through the service either as a REST caller or a full FeedSync endpoint, then you can start to pull that data. And that can pull from devices as well.
So one more question.
Sure.
It seems like live folders is much faster than mesh folders. And it also appears like you're moving a lot of data without charging us anything, like via Messenger. So how are you going to scale that to, obviously in the end there won't be probably two systems, but one of them is much faster now. So
right. So let me talk about what we're doing with the development environment and the production live mesh environment. And so today those are two side-by-side environments. The live mesh environment certainly has a higher bar in terms of the quality bits that we want to get out there, knowing that users are relying on this system. Today, the development cloud or the development side-by-side environment, we intend to rapidly iterate and basically is intended to get feedback as quickly as possible. So we will be driving the quality up in the technology preview environment. And so you'll see that happening. You'll see performance work start to happen there. And then we'll learn from the system as people are using the system. It's a different pattern than live folders. We learned a lot through building live folders. I think we're going to learn even more when people start to do interesting things with mesh objects. We're starting to see that already. The system, behaves differently when it's not a live folder and people are representing different data and there's different characteristics to that data. So what you'll see is as we mature functionality in that developer platform cloud, we'll bring that over to the live mesh cloud. Does that answer your question? Go ahead, over there.
How did you implement that Silverlight window on the desktop?
The Silverlight window, so first I'll say, if you didn't get a chance to go to the Mesh Applications talk yesterday, Arash, who's in the audience today, did a great talk yesterday on Mesh Applications. It's online. Go check it out. Lots of great detail there. But the short version is that is actually an application host, application container hosting Silverlight and running it offline. It's a Win32 application that hosts an IE control that's hosting Silverlight.
And the web server being where?
Local host. The live operating environment actually serves up both the application and the application's data. And then the live operating environment will then synchronize that back to the cloud. So you'll get consistent experiences both on the cloud and the client.
So you have to be connected.
You do not have to be connected to run those Silverlight applications. They're fully cached down to the client and synchronized down to the client. So the application, the full application will come down, and then the data will also come down. And as data is manipulated, it's actually served out of local host, which can be offline. In fact, Arash did some great tricks yesterday where he pulled out his network cable to accentuate the point that you can run these offline. So if you get a chance, I highly recommend checking out that talk online.
Okay, thank you.
You're welcome. Over here.
Couple of questions. From a development standards perspective, are you running a VM with production and developer mesh on your native OS or vice versa, or a fast user switching, which is sort of a variation on that?
Mm-hmm. So are you asking specifically about our cloud environments?
No, how you would develop on the desktop.
Oh, I see. Mesh applications?
Yep.
Yes. So today with mesh applications, you can develop and you can publish to the cloud. So that's what we provide a sandbox. So we have tooling within VS where you can hit F5 and then that application is published to the cloud. Very shortly, we will be adding the functionality where you can publish it to the local runtime. So if you have the developer SDK installed, it includes the live operating environment that runs locally. And then we'll enable the scenario where you can hit F5 and it publishes locally and then gets served out locally. So you won't need another VM or another environment to do your development in.
I'll come up and ask the couple
Okay, yeah, feel free to follow up with me offline. Question?
So I can understand how you have a common storage model in the cloud and locally, and you have a common client model in the cloud and locally, or it's always local. JavaScript and HTML. Mm-hmm. Is there a model for server-side code to be remote and local? So a .asp file, basically?
It's a good question. The question, it was mic'd up, so I don't have to repeat it. So we have looked at ASP.NET and hosting it and having symmetry on both the server and the client. Something we're looking at. People have expressed interest in it, not in the near-term roadmap. Okay, thanks again. I'll stick around if people have questions.